Okay, so last discussion we left off on this problem here. I said it was a special case because our complementary solution actually matches the term in our particular solution, so we had to multiply the particular by x to differentiate it. Oops, that's the wrong color. So I was going to continue on with this, but there's actually plenty of examples hitting this exact topic in the worksheet. So I'll leave off on this guy and jump straight into the worksheet, and you'll see more of these types of problems. So when you have a particular solution that matches the form of the complementary solution, then you're going to have to multiply whatever terms that matches by x, okay? So then if that doesn't work and it still matches, then you're going to have to multiply through by x squared. So now let's look at example problems. So I'll start with the worksheet. So this is a little bit of a review. First problem is 9y double prime plus y equals e to the 2x. And for all of these, we're using the method of undetermined coefficients to come up with our general solution. So we've already mentioned that we start with our auxiliary equation and find the complementary solution. So that'd be 9r squared plus 1 equals 0. So r is going to be plus or minus 1/3 I. Okay, so y complementary will be C1 cosine 1/3, so 1/3 is beta x plus C2 sine of beta x, right? So alpha is 0 in this case, so our e to the alpha x just becomes 1. That's our complementary. Our particular is going to reflect this guy here, the right-hand side, g as a function of x. So we have the coefficient times e to the 2x. We want to find the first derivative and the second derivative. So here's the first derivative, 2x, y double prime is going to be 4 a e to the 2x. So let's plug this into our differential equation. 9 times y double prime will give me 9 times 4 a e to the 2x plus a e to the 2x. All right, so this will equal our right-hand side, which is e to the 2x. And of course, this will be equal 36 plus 1, so 37a e to the 2x. E to the 2x. So a should equal 137. Now y is complementary plus particular. So this is C1 cos 1/3 x plus C2 sine 1/3 x plus 137 e to the 2x, right? Yp. So there's our general solution. So number 2, y double prime minus 4y prime plus 5y equals e to the minus x. Let's start with our auxiliary to find our complementary solution. R squared minus 4r plus 5 equals 0. Negative b, so that's negative 4 or positive 4, plus or minus e squared 16 minus 4ac, so 20 over 2a. So this is our r's. So this will be 4 plus or minus negative 4 over 2. So this gives us 2 plus or minus I. So alpha, beta, right? Alpha plus or minus beta. Our complementary solution then is going to be e to the alpha x, 2x, times C1 cosine of beta, which is 1x, plus C2 sine of beta x. So there's our complementary. Our particular, our trial particular, is going to be a coefficient times our g as a function of x, this here. And we don't have any issues here of of the particular solution matching any of the complementary terms, because this is e to the 2x and there's cosine. So no, we don't have to multiply anything through by x, so we're good there. So we need to find y prime. That'll give us negative a e to the negative x. Y double prime particular will bring us back to positive value, e to the negative x. So we plug this in now. We plug this into our differential equation. We'll have a e to the minus x plus 4 a e to the minus x plus 5 plus 5y, so 5 a e to the minus x, and that equals our right-hand side, which is e to the minus x. Let's sum this up. We have 10 a e to the minus x equals this. So our a has to equal 1/10. And now our y equals our complementary plus particular. So we have e to 2x c1 cos x plus c2 sin x plus 1/10 e to the minus. Okay. These are pretty straightforward. Number 3. Now we have two terms, so we're going to have to use the superposition principle. Let's first deal with our auxiliary equation, r squared minus 4r plus 4 equals 0. This will give us a repeating root, r equals 2. So our complementary will have c1 e to the 2x plus c2. Now we have to multiply the second term by x because it's a repeating root. This was labeled as case 2 in our homogeneous second order differential equation section. Our particular will be this the trial for this one, which is ax plus b, and then the trial for this one, which is plus c cosine x plus d sine x, right? So yp, actually I'm going to write it the other way just because the solution writes it this way. It really doesn't matter. C sine, I'm going to switch sine and cosine so it matches what I have on my sheet. Okay, so it should be c sine x, d cosine x, but it really doesn't matter. Y prime is going to be a plus c cosine x minus d sine x.
Wait, sorry, do we ignore the negative sign in front of the sine x?
Yeah, you don't have to consider the sign when you're doing the trial because you're putting these coefficients, arbitrary coefficients, so that takes care of whatever sign when you find it.
Okay,
yeah.
Thanks.
Yep. So you could have put a negative there, but it really doesn't matter because when at the end of the day, when you solve for your coefficients, it'll fix itself. So I just like to keep everything positive. So y double prime p is going to be negative c sine x minus d cosine x. Okay, so now we can plug everything in. Y double prime is negative c sine x minus d cos x minus 4y prime is going to be minus 4a minus 4a minus 4b. Oh, wait, I'm multiplying the wrong one here. Should be y prime. Okay, so minus 4 times y prime is going to be minus 4a minus 4c cos x minus 4d sine x. Sorry, this should be plus. Okay, and then plus 4 times y, which is this guy here. So 4ax plus 4b plus 4c sine x plus 4d cosine x. All right, so this was y double prime. This is minus 4 times y prime, and this is 4 times y. And this equals our x minus sine x. Okay, so let's group some terms here. I'll group all the sine terms. All right, I'll group all these sine terms on the left-hand side, so it's a little bit cleaner. So we can have, we'll have 4d plus 3c times sine x. Right, I just grouped these three terms. Now I'll group all the cosine terms. So we'll have 3d minus 4c cosine x, cos x. I'll group all of the, well, there's only one ax term, so 4ax. And I can group all of the constants, which are minus 4a plus 4b. So minus 4a plus 4b. We should have a minus here. Okay, and this still equals x minus sine x. So now let's solve for the coefficients. So if we're just looking at x terms, we have this guy, 4a on the left-hand side and 1 on the right-hand side. So we can solve for a directly to be 1/4. Let's look at all of our constant terms. We have these two guys and nothing on the right-hand side. So we have minus 4a plus 4b equals 0. And we can plug a into here. We get b equals 1/4. We look at all of our sine x terms. We have 4d plus 3c. And this equals -1. And we'll need another equation to solve those two. So let's look at cosine x terms. We have 3d minus 4c equals, there are no cosine x terms on the right-hand side, so it'll be 0. So now we can solve these two system of equations to get c and d. So what can we do here? I can multiply the bottom equation by 3/4. So this will give me 9/4 d minus 3c equals 0. So when I sum these two equations up, we'll get 4 and 9/4 d equals -1. What is 4 and 9/4? 16, 25/4. This is 25/4. So d is going to equal -4/25. And let's plug that back into one of these equations. So 9/4 times d, -4/25, minus 3c equals 0. So we have minus 9 over 25 equals 3c. Therefore, this will be 3 times this, right? So c will equal negative 9 over 75. If we divide top and bottom by 3, negative 3 over 25. Okay, so there's our two coefficients. Now we just plug everything in to our yp. So yp was given here. We just plug the coefficients back in, right? So we have a, which is a was 1/4. 1/4 times x plus b, which is 1/4, plus c sine x plus d cosine x. So c is minus 3.5 sine x minus 4 over 25 cosine x. Okay, so there's our yp, and then yc, or y is going to equal to yc plus yp, and I'm not going to write that out. We'll just combine this guy and this guy here, right? So a little bit more tedious of a problem. Number 4. So any questions on that last one? I hope that one made sense. It was just mostly algebra towards the end here, right? So y double prime minus 4y equals e to the 2x. Let's start with our auxiliary. R squared minus 4 equals 0. R is going to equal plus or minus 2. So our complementary will be c1 e to the 2x plus c2 e to the minus 2x. Our y particular will be in the form a e to the 2x, but notice now, so this was the special case that I was talking about. We have this term here that essentially matches our particular, so we should multiply our particular by x, and now all 3 of these terms are different, right? So when we go to create our general solution, we'll have a e to the 2x times x plus c1 e to the 2x plus c2 e to the minus 2x, right? So we'll have all different terms. So now let's solve for a. So we're going to need yp prime, which will be a e to the 2x, so product rule, 2x e to the 2x, double prime, we'll have to do another product rule, so 2 e to the 2x plus 2 e to the 2x plus 4x e to the 2x. Simplify this, we can combine those first two. So now let's plug into our differential equation. So y double prime is going to be a 4 e to the 2x plus 4 minus 4 times y. So 4 times y is 4a e to the 2x times x. This equals e to the 2x. Okay, so now let's gather our terms, and it looks like we will have we have this. That's just e to the 2x. So a times 4 is going to equal to, so we're gathering all the coefficients for e to the 2x. This will equal 1, so A should equal 1/4. And we don't have any other coefficients, so we're done. So our YP is going to be 1/4 e to the 2x. Oh, times x. I forgot. So our y homogeneous, or y general will be y complementary plus y particular. And we found our complementary here, right? So this will be 1/4. There's our solution. Okay, so now we can look at the next set of problems, which now deal with initial values. So same concept as before. So now these are all initial value problems. Y double prime minus 2y prime plus 5y. Now we're given two initial conditions because this is a second order. Conditions. Okay, so just like we did before, we're going to solve for our general solution, which means we need to start with our complementary. This one will be r squared minus 2r plus 5 equals 0. Minus b, so 2 plus or minus b squared minus 4ac over 2. This will give us 2 plus or minus 4i over 2, which is 1 plus or minus 2i. So these are my r's. My complementary will be e to the x, alpha x, c1, cosine of beta x plus c2, sine of beta x. My particular is going to be a sine of x plus b cosine x. Let's find the derivatives. A cos x plus minus b sine x. Double prime will be negative a sine x minus b cos x. We plug into our differential equation. So we'll have negative a sine x minus b cos x minus 2 times y prime 5 times y of a sine x plus 5b cos x. This equals our right-hand side sine x. Okay, we can gather terms. So let's gather all of our sine terms. Negative a plus 5a, so it's 4a plus 2b sine x. We'll get our cosine terms, this one, and this one. So we have plus 4b minus 2a cos x, and this equals sine x. We'll gather the coefficients for sine. So we'll have 4a plus 2b equals 1. For cosine, we have 4b minus 2a equals 0. I'm going to multiply this bottom one by 2. This gives me minus 4a plus 8b equals 0. If I sum up 1 and 2, I get 10b equals 1, so b equals 110. And then a should equal, plug in into number 1. 4a equals minus 2 times b. So a equals -1 divided by 4. This equals -120. Okay, so my particular should equal a, which is -1/20 sine x plus b 1/10 plus x, y. Let me make sure this is right. Okay, so y is going to be homogeneous. Okay, e to the x times c1 cosine 2x plus c2 sine of 2x minus 1/20 sine x plus 1/10 cos x. So here's my general solution. We'll have to find y prime eventually, so let's just find it now. So this first term, we'll have to do product rule. So derivative of the first times the second plus the first times derivative of the second. So we'll have negative 2c1 cos 2x plus 2c2. Oops, this should be sine. This should be cosine. Minus 1/20 cos x. Keep doing that. Cos x minus 1/10 sine x. Okay, so there's our derivative. Let's plug in our initial values here. So they're both 0 and 1. So y at 0 equals 1. So this will be 1 times c1 cos of 0 is 1. So c1, this sine term will go to 0. Sine term will go to 0. And we have 1/10, just 1/10. And this equals to 1. So c1 is going to equal 9/10. And now let's plug in for y prime. This equals to 1. So we'll have c1, sine is gone. This is gone. Plus c2 times c2 coming from this. And then we also have a minus 1/20 coming from this guy. And this goes to 0. So we know c1 from our previous equation. So we have 1 equals 9/10 plus 2c2. Well, why do I have 1/12 there? This should be 1/20. So let's multiply through by 20. 20 equals 18 plus 40c2 minus 1. So 21 minus 18 is 3. So c2 is going to be 3. Okay, so now all we do is plug into our general, so we plug these coefficients into our general solution. So we have y equals ex. C1 is going to be 9/10 cos 2x plus C2, which is 3/40 sine 2x minus 120 sine x plus 110. Okay, so there's my solution to our initial value problem. Hopefully all the algebra is correct. Okay, so let's look at number 2. And our initial values are y at 0 equals 0, y prime of 0 equals. Okay, so my auxiliary equation is going to show that r squared minus 1 equals 0, so r is equal to plus or minus 1. From this, our complementary is c1 e to the x plus c2 e to the minus x. Our particular is going to be the product of these two trial solutions, so ax plus b times e to the 2x. Let's find our derivatives. Yp prime is going to be a e to the 2x product rule to ax plus b e to the 2x. Y double prime yp is going to be 2a e to the 2x plus 2a e to the 2x. So another product rule here. Okay. So let's actually, we can simplify this a little bit and say 4a e to the 2x plus 4ax plus b e to the 2x. So now we plug into our differential equation. We get 4a e to the 2x plus 4 times ax plus b minus y. So y is ax plus b that equals our right-hand side. We can subtract one of these from this guy, so we have 4a plus 3. Okay, now let's sum up all the coefficients for x e to the 2x. So we only have this term here. So we have 3a that equals 1. Therefore, a equals 1/3. E to the 2x terms, we have 4a and 3b. And the right-hand side is 0. We know a, so 4/3 plus 3b equals 0. Therefore, b should equal negative 4/9. So there's our coefficients. So yp should be 1/3 x plus minus 4/9 times e to the 2x. So our general equation is going to be these two together. Plus our complementary. So that means now we can go ahead and plug in our initial values here. So this means we'll need our y prime. So this would be 1/3 e to the 2x plus 2 times product rule of these two terms, 1/3 x minus 4/9 e to the 2x plus c1 e to the x minus c2 e to the minus x, right? So let's plug in our initial value for y. So y at 0 equals 0. So this gives us minus 4/9 plus c1 plus c2. And then y prime at 0 equals 1. Yep. Y prime at 0 equals 1. So this gives us 1/3 minus 4/9 plus c1 minus c2. Okay, so now we have another system of equations. Here and here. 1 and 2. So if we combine these two together, oh, I forgot the 2. I forgot to multiply the 2. So if I multiply the 2, we should have 8/9 here, right? So those two together will give me negative 5/9 plus c1 minus c2. This equals 1. And then let's see, we have negative 4/9 plus c1 plus c2 equals 0. So let's sum these two up. We have negative 1, so 5/9 plus negative 4/9 is going to be negative 1, plus 2c1 is equal to 1. So c1 is equal to 1. And I'll plug into the top equation, negative 5/9 plus 1 minus c2 equals 1. This will cancel out, so c2 is equal to negative 5/9. So I plug these into my general equation. So I have 1/3 x minus 4/9 e to the 2x plus c1 is 1 minus 5/9 e to the minus x. So here is the solution to my initial value problem. Okay, so the steps should be pretty clear. Algebra can get a little tedious and tricky, but the steps should be pretty straightforward at this point. I'll skip number 3 just so we can hit the last, make sure we get through the last 3 problems, which are just setting up our trial solutions. So these are 3.1. So this one, we just want to come up with the trial solution. So find trial solutions. Y double prime minus e y prime plus 2y equals e to the x plus sine x. So again, auxiliary. So we have r squared minus e r plus 2 equals 0. We'll use a quadratic formula, so negative e plus or minus e squared minus 4ac, so that'll give me minus 8 over 2. Okay, so in this one, we have to know that e squared is less than 8, so this is going to be a complex number. So what I'm going to do is I'm going to factor out factor out the I from this. If I factor out the I, the sign switch on the inside, right? So now E squared is like 7 point something. So now we have E over 2 plus or minus I over 2 root 8 minus E squared. So here's my alpha and beta. So Y complementary will be E to the alpha x times C1 cosine beta, which is root 8 minus E squared over 2x plus C2 sine beta 8 minus E squared over 2x. Right, so there's my complementary. My particular is going to be the superpositioning of this and this. So it'll be A e dx cos x plus C sine x, right? So my general solution will be this plus this, right? YC plus YP. Okay, so number 2, 3.2, we have Y double prime plus 2Y prime plus 10Y. Let's find our complementary solution. So quadratic formula, minus 2 plus or minus E squared minus 4AC over 2. So this will give us negative 2 plus or minus 6I over 2. So minus 1 plus or minus 3I. So alpha and beta. Our complementary will be e to the minus x C1 cosine 3x plus C2 sine of 3x. Now let's do our particular. So this would be a little tricky. So now we have 3 terms here, right? So let's first handle this one. So this would be ax squared plus bx plus c, right? And then this one's easy. We just multiply e to the minus x. The cosine 3x means that we'll need a term with sine and cosine, so that means we're going to have to double this, right? So we'll have 3x here, and we need to rewrite all of this over again with new coefficients with sine x. So this will start from dx squared plus ex plus f e to the minus x sine 3x, okay? And we have to do this because of this trigonometric part. But now we're not done. We can't just simply combine yc and yp here, because if you notice, we have similar terms. So if you actually multiplied this out in y complementary, we have a constant times e to the minus x times cosine, a constant times e to the minus x times sine of 3x. And we actually will have the same case here, right? If we multiply this out. So what does that mean? We should multiply our y particular by x. So if we do that, so we need to multiply yp by x. And that's so that we don't have similar terms. So our new yp is going to be ax cubed plus ex squared plus cx e to the minus x cosine 3x ex cubed plus ex squared plus So now your general solution will be YC plus YP. YP and YC. Is that clear? One more, 3.3. Double prime minus 6y prime plus 9y equals e to the 3x plus x sine to the 2x. Complementary solution will squared minus 6r plus 9 equals 0. So minus 3 squared equals 0. So complementary is c1 e to the 3x plus c2 x, because we have a repeating root now. Our particular will be the superpositioning of these two. So a e to the 3x plus bx plus c sine of 2x plus dx plus e cosine of 2x because of this, the trig. And let's make sure. So now we have a e to the 3x that matches with this one. But if we simply multiply yp, that term by x, it's going to match this one. So this is the case where you have to multiply by x squared. So this will be a x squared e to the 3x. And then now we can just keep these the same. You don't have to multiply anything to that. Dx plus c sine of 2x plus dx plus e cosine of 2x. And of course, y is equal to yc plus yp. Okay, so that's all I have for you today. So thanks for joining me. If I'll post the solutions to this on B courses right now.
Thank you.
Thank you. Bye.